For one of the guided reading assignments, you must turn an asset beta into an equity beta to use as part of your calculation of the WACC. You will use this calculation for several cases in your second corporate finance course. Consequently, I am describing the process for how we unlever and relever beta in this video. If you look up the beta of a company, the beta that you see is its equity beta. That is the beta that you use in CAPM to calculate the cost of equity. If you are given an asset beta, you need to lever it. When the company has more debt, then that will increase the cost of equity, the return on equity, because now the return to the equity holders is riskier since the company must pay the interest payments on the debt before returning cash flows to the shareholders. We are going to use a formula known as the Hamada equation, which you can see on this slide too, to lever our asset beta. The Hamada equation is an attempt to quantify the higher risk due to financial leverage. That is the use of debt. The symbols used in that equation are on this slide 3. Next, you will use that levered beta to calculate the cost of equity using the CAPM, capital asset pricing model. Then you will use that cost of equity along with the after-tax cost of debt to calculate the WACC. To show you how to unlever and relever beta, we will look at a sample problem of the fictional company. You can pause the video to read the problem. We will work the problem in Excel. So let me do a new share to bring up the Excel. We have a fictional company where we need to unlever its equity beta and then relever it because we are assuming there will be a change in the capital structure. The Hamada equation is in row 7 here in bold of the Excel. The unlevered beta of a firm represents the business risk as if it had no debt. The unlevered beta is also known as the asset beta. The Hamada equation shows that the levered beta is equal to the unlevered beta, beta sub u, multiplied by 1 plus the debt equity ratio multiplied by 1 minus the corporate tax rate. If there weren't any taxes, we would know that having debt is just making the firm even more risky. But having taxes means that debt is a little bit beneficial because you can deduct your interest expense from your business's other costs and business revenues to get a lower taxable income. Interest expense is tax deductible, and that is why we multiply the debt equity ratio here by 1 minus the tax rate. Having a positive tax rate reduces the impact of leverage on our risk. We need to calculate a project beta that reflects the risk of the project or a company beta that reflects the risk of the company, and we need to pay attention to the use of debt in this capital structure. Now, our fictional company originally had a debt equity ratio of 2 divided by 7, see cells C or D in row 8. But it will issue more debt, perhaps to buy back stock or for some other reason, so that its new debt equity ratio will be 0.9, as shown in column N, row 10. When we unlever the theta in rows 8 and 9, we must first calculate what is in the square bracket in our Hamada equation. The corporate tax rate is shown in cell N4 as 30%. So 1 minus the tax rate is 0.7. Multiplying 0.7 by the original debt equity ratio of 2 divided by 7 gives us 0.2. Add 0.2 to the 1, and you see that in cell F8 and other places, 1.2. That's the term in the square brackets. Then we divide by the original beta of 1.5 to calculate the asset, also known as the unlevered beta of 1.25. You see that in cell B9. That is the answer to part A of the problem. Next, we relever the unlevered beta with a new debt equity ratio equal to 0.9 using the Hamada equation. 0.7, 1 minus the corporate tax rate, times 0.9. The new debt equity ratio equals 0.63. Add 1, get 1.63, and then you multiply 1.63 by the asset unlevered beta of 1.25, and that gives you a new levered or equity beta of 2.0375 in cell F10. That is the answer to part B of the problem. Next, we use the new levered beta in our CAPM equation in cell C12. The risk-free rate is 4% as shown in cell N2. The market risk premium equals the expected return in the market of 8.5% minus the risk rate of 4%. So the MRP, market risk premium, is 4.5% and is calculated in cell N4. The return on equity with the new beta is calculated in cell B12 as 13.16875%. That is the answer to part C of the problem. To calculate the WACC, weighted average cost of capital, we need the new cost of debt, which is given in cell N1 as 5%. We also need the corporate tax rate, which is 30% in cell N5. And we need the percent debt and the percent equity in our financing. We are assuming that this company does not use preferred stock, only debt and equity. To calculate the percent of debt, which is known also as the weight of debt, we need to convert our new debt equity ratio into the percent of debt. That process is described in rows 16 and 17 on the right here in the Excel. The calculation is as follows. If debt equity equal 0.9, that implies that debt equals 0.9 equity. So then we can solve for the percent of debt, which is the weight of debt, W sub D, which is equal to debt divided by debt plus equity, D divided by D plus E. As shown in cells I17 through Q17, the percent debt is equal to 0.9 E divided by 1 E plus 0.9 E, which equals 0.9 divided by 1.9, which equals 0.47364 and is calculated in cell N11. The weight of equity equals 1 minus the weight of debt, so 1 minus 0.47368 15. As WACC equals percent equity times the required return on equity plus percent debt times the interest rate on debt times 1 minus the tax rate. The answer in cell D16, 5.888%. It's calculated as a decimal in cell B16, and it's a percent in cell D16. So now you know how to unlever equity betas, lever asset betas, calculate the required return on equity, and calculate the WACC, which you can then use to value a company or a project using the DCF, discounted cash flows method. Thank you.